looking at B3, I can prove triangles are similar by applying the side similarity theorem. So this is our next shortcut, okay? Just like the name says, side, right? As long as we have 3 sides, we can prove our triangles are similar or not similar, right? So 2 triangles are similar. If all 3 sides are proportional. So again, remember, proportional means equal fractions. Equal. I'm just going to rewrite that. Equal. There we go. Fractions. Okay. So the easiest way to set this up is to do, in each example, you're going to do the smallest side over the smallest side. And set it equal to the middle side over the middle side. And then do the biggest side over the biggest side. Okay? And if all of those are equal, then you can say your triangle blank is similar to triangle blank by side. Okay. These fractions, we have to think back to what we did in target A, are still our n over O. So we still want to remember that our scale factor equals new over old. So I'm going to call this my old and this my new. So I'm going to start with small over small. My smallest side and this, right, so I'm doing new, and my new triangle is this 9. My smallest side of my old triangle is this 6. Equals. Now I've used those sides, so now I want to do my middle or my next smallest, right? In my new triangle, right, I would go to 12 next. In this one, well, 8 would come before 10. Right? Let's give those a marking. Let's underline them. And then again, new first, so I'm going to have 15. Old is 10. So I want to check if these are equal. And to check if they're equal, right, all we have to do is type them in our calculator, and it will reduce the fraction for us. If you are confident on your fraction reducing, you can do it without the calculator. So we have, hold on, don't know what's happening. There we go, 9 over 6, which is 3/2. Then we have 12 over 8, which is also 3/2. This is looking promising. And then we have 15 over 10, which is also 3/2. Okay. So then, these are all the same. 1, 2, 3, right? So now I can do my triangles. Now this is where I have to be very careful with naming, okay? I'm going to start at S. And I'm going to go down the side with the red that I circled, and then across the side I underlined. Same thing here. I want to go down here, across here. So I have to do XVW. Okay. So with those, we still have to be very careful of how we are naming them. All right, looking at example 2. Is there another page of this? There is. Okay. Same thing. I'm going to start with, this is going to be my old to my new. Okay. So I'm picking the smallest side on my new. Right, we're still doing small over small, middle over middle, and big over big. So my smallest side is 22. Right? My smallest side here is 32. Then after 22 would come 30. After 32 comes 45. Making sure I underline those, right? And again, this really helps me know which sides I've already used. And it helps me when I'm deciding the order of my letters. And then my biggest side is 40, and my biggest side here is 60. So again, reducing my fractions, I have 22 over 32, which is 11/16. 30 over 45 is 2/3. And then 40 over 60 is 2/3. 11/16 is not equal to 2/3. So not all of these are equal. So I cannot say they're similar. These are not similar. Okay. Right. Looking at our last example here. Again, using this small over small, middle over middle, big over big. We have our new old triangle and our new triangle. And again, we're still doing new over old. So I have to choose the smallest number on my new, which is 20. And I have to do my smallest number, which is 12. Then I have to do my next number, well, 20, 25, 35, right? 25 comes next. Sorry, I forgot to circle the number 12. So that's 25, and then 12, 15, 21, right? So 15 comes next in my order. And then my biggest is 35 and 21. I can't remember to underline or circle. So for sake of time, I'm just going to reduce them. 20 over 12 is 5/3. 25 over 15, I divide both of those by 5, 5/3. 35 over 21, I'm dividing both of those by 7, 5/3. So 5/3, 5/3, 5/3. They are all equal. So I'm going to go from A to B to C. Similar to, again, I'm going to go across over my red and then, or my circled one and then my underlined one. So I want to go E, F, D. Okay. So triangle ABC is similar to triangle EFD. By, side, side, side. Okay. We're not going to worry about the next side, the proof on that last side. We're going to skip that. Okay. So go ahead, get started with your activity.